Hello everyone, and welcome to Vintage Machine Shed. My name is Steve, and in this video I will be sharing with you how I remanufactured the rocker arm assembly for a Allis Chalmers WD45 gas tractor engine. So after we finish up the rocker arm assembly, we're going to move on to doing some head work, and then to do some crank work, checking in the block, and then on to some piston and sleeve work, and carry on from there, whatever we need to do next. So I have not created any videos for the past 6 years, and before that I've only created a handful. So I ask that you bear with me as I figure out video creation. Please subscribe, and I hope to keep the videos coming. Something else I wanted to mention before we get started on the project. Last winter I pulled the engine out of this tractor and had torn it down. Had not recorded any video then. So this winter I'm picking back up on it again, and it was part way into it this winter, and that's when I decided to start recording the video. I'm not a professional engine rebuilder, or I'm not an expert on anything I'm doing here. I do have a background in tool and die and some CAD design work as well. The machines I'm using are just in my personal workshop. They aren't specifically designed for engine rebuilding. Here's a brief tour of the machines that I have. Wells Index milling machine with vertical and horizontal head. This Acer milling machine, a little bit smaller. Coming over here to the surface grinder, it's a Gardner brand. And then onto the lathe, it's a Clausing Colchester 15-inch. I use what I can, and sometimes I have to improvise with what I have. If there's something I can't do, I will send it out to a local automotive type machine shop. I'm not trying to build anything to perfection, but when I tear things down, I measure and reevaluate what may need reconditioning or replacing, and what makes sense for my budget to replace. So I usually feel I'll have a pretty good result when I'm done with it, but I don't like to put more money into something than what it's worth. As long as you set aside your time, that certainly is worth something, but I don't include that in what it's worth. I hope you enjoy these videos and find something useful from them. So I don't have any video before pulling the engine out of the tractor. I have this still shot here, and then I have the tractor behind the barn covered with a tarp. Show you what's left of that. So let's walk around to the back side of the barn and take a look at the tractor. I purchased this on an online auction and really only bought it for the front weights on it. So my brother and I picked it up one afternoon, and it was from an older gentleman. He helped us load it on the trailer, and he didn't really know a lot about it. He bought it. He knew it had some issues. He said the motor would need to be rebuilt, and he was, I think because of age, he just couldn't deal with it anymore. So it had some new parts with it, a new generator, new tie rod ends were on it already. It had another steering wheel with it. The rear tires are pretty good shape. It had an older repaint, it looks like. So walking around to the back, it's fairly complete. The drawbar is not on it now, but I do have one for it. Had a rear wheel weight on the one side. And so anyhow, I fiddled with the motor, did some wiring on it. Got it running, and it had a bad leak in the oil pan. I actually pulled the pan off, put a new gasket on it, and was able to run it. It ran okay, but not quite right. I don't know quite how to describe it. I've heard these motors run many a time, so I know what they should sound like, but I couldn't quite put my finger on what was wrong with it. I did a leak down test and on the cylinders, and determined the rings were probably worn out. They were having a lot of compression go past them, so I decided at that time I'm going to make it into a winter project. This was last winter. I pulled the head off and found out the sleeves were worn really bad, beyond what would it be worth putting new rings in. So, and it had been re-sleeved at one time because it had oversized sleeves in, and so it had some motor work done before. But obviously running with the air cleaner off, shown in the picture, that that probably did a number on the rings. So I decided to go a little further into it, and of course as I get into it, it's turned into a bigger and bigger project. So, but I thought it would make good YouTube content, so I'm gonna keep pursuing it. So you hear me throwing around words like thousandths of an inch. If you were to take an inch, let's say this example, here's an inch. Now it's really bigger than that, but if this were an inch in distance here, and you were to divide this inch in 1,000 pieces, and you took one of those pieces out, that would be 1,000ths of an inch, or 0.001 of an inch. Now to put that in perspective, if I measure this very piece of paper here, it's about 3 thousandths, just over. So 3 of those 1,000 pieces of an inch would be 1,000ths of an inch, or 0.001. Here's a view of the rocker arm assembly, disassembled, and the individual components. The parts to the far right are just for a jig that I made for boring out the rocker arms themselves. So looking at the rocker arm shaft, I had to turn that down on the lathe to true it back up again because it had some wear on. And then the 4 rocker arm shaft support components, those had to be bored out, and then a sleeve or a bushing put in them. Now they do not pivot, but yet they still wore. And then the other 8 parts, or the rocker arms themselves, had to be bored out, and then a bushing had to be installed in them. And one other component on the rocker arms themselves. On the tip of the rocker arm, there's a radius area that touches off on the stem of the valve, which pushes on the valve. That was kind of distorted and worn over time, so that had to be redressed as well, and a new radius was put on that, and I will roughly show you how I put that on also. And here's the rocker shaft. Now I ended up turning this down on my lathe. Here is the lathe I turned down the rocker shaft on. I just reset it up. I cut about approximately half of it at a time, indicated in the 4-jaw chuck, and then I have a live center that fit nicely on the end here. So by doing it half at a time, it worked out quite well. I kind of had a blend back here again into every time I flipped it around, and it worked out quite well, and I shined it up with some emery cloth. I did it in 2 separate settings because it's fairly long, and trying to get run out to a minimal. I was able to get it within about a 1/2 thousandths, and I polished it up with some emery cloth. This is a hollow shaft. I thought it would probably be hardened, but it did not appear to be. So it looks like it, I don't know if the video camera here will focus in on it, but it appears to be a rolled shaft. Yeah, it's not showing up well. I'm not quite sure how it was created, but I considered making a new one, but the time involved would be pretty substantial. So I went ahead, turned it down, and it actually came out quite well. It started out about 0.865 inch, 865 thousandths, which is a little under 7/8 of an inch. And now I'm down to 850 thousandths. So to compensate for all that, I had to take these pedestals, I bored them out, and created a steel bushing and press that in there and reboard to get it to fit to the new 850 thousandths inch diameter. I did that for the 4. Here's a view showing the rocker arm shaft support. All 4 are clamped in a vise and ready to be bored out. I indicated each one individually and entered that number into the digital readout so I could recall and come back to them when needed. Here's the boring head I used to bore out each one of these rocker arm shaft support. Had to first bore it out to create an opening for to accept a bushing. Then I created a bushing on the lathe and I left the ID a little bit oversized and then pressed each one in and then reset up on the milling machine again and bored them out to a finished size to fit the rocker shaft. Similar thing on the rocker arms. I did that as well, except I installed the bronze bushing instead of the steel bushing. Here's a fixture I made up to hold the rocker arms for boring them out and then reboring them out again after the bushing was installed. So I set each rocker arm here. I can just do 2 at a time. On here like so, get them reasonably centered. This actually clamps down into the vise in the milling machine. Then I made a cap plate that goes over top. This is what actually I clamp down to hold when I bore them out. So anyhow, these bolts are tightened down. And to get a more accurate centering of these, I made these locator pins. Now they won't fit in now because the bushing's already in, but when the rocker arms come off the rocker shaft, they have some wear on them, but this centers them pretty closely. This drops all the way down in here. This pin locates it in the bottom plate, and then this diameter here locates it inside the rocker arm itself. And then this top diameter locates it inside this top clamping plate. So when they're both in here, you get a fairly accurate centering of where the bushing has to go in these arms. That way it eliminates the need for having to indicate them in every time. So after these are clamped down, I bore them out. Of course, remove the plate, put in the next 2 arms till all 8 of them are done. And then when I go back to rebore them out after I have the bushing made, then I do have to, I do not at this time anyhow, I have another plug to fit the to fit in here when the bushings are pressed in. If I make a lot of these, I'll probably make another similar locator as these, but I did then at that point dial indicate where the bushings are, and then I left a little finished size on here to finish bore them out to the exact size I need to fit around the rod here. As a side note, I looked through my stash of parts here and come across some other rocker arms I had. Now this was came from a WD45, and of course over the years I don't know the history on this whole thing, what may have been done to it over the years. I don't even know if this could have been an original arm, but these appear to have had either they were manufactured this way with like a bushing already installed. So I essentially put a bushing within a bushing. And again, I don't know if that's factory or if that was another modification done by a previous owner. And then I come across this other arm, and if you look, I don't know how well it shows up in the video, but you can see the other one on the right side has the flange here. The ears come out further. They seem to be cast into the arm here, whereas the other ones have a shorter flange on and then a bushing slid through. But you'll also see this one already has a bushing installed, so I don't know if that was, again, another shop had done that at one time in its life, or if that's the way it came from the factory. I believe these are either from an Allis Chalmers 170 gas engine or a Gleaner E engine. Possibly could have been from that same era. But so anyhow, if I had known this, I probably would have used, when I had these, I probably would have used these rocker arms, because I could just have pressed out that bushing and put in a new one. So it could have saved me a lot of work. But anyhow, I didn't know I had that, but I do now for a future project. This tool here is called a radius dresser, and it's also an angle dresser. You can create angles and internal and external radius on a grinding wheel in a surface grinder. And that's how I created the 5/16 radius on the rocker arm. And this tool here, there's a diamond tip here. From that diamond tip, I know that the center line of this tool is 3.4 inches up from the main surface here. So then I would take the tip of this and move this up the radius. I want to put a concave radius on that grinding wheel, so I'm going to move that an additional 5/16 inch up above the center line of where this tool pivots. So then I'm just spinning this, and I know it's hard to see in the video, but it's actually putting a concave radius on that grinding wheel. And here's the grinding wheel I used. Obviously it's not in the grinding machine, but we'll walk over there in a minute and show you the process, or I'll show you the wheel installed in the surface grinder. This tool can also be set to dress angles on a grinding wheel. You can see there's a degree scale here. So you can turn it to an angle and lock it into place. And it's kind of hard to show you that here with one hand, but you can see this thing moving. That's how I put an angle on the grinding wheel when I reground the valves, and I'll show you that later when we get to the head project. Here's a surface grinder. What that does, there's a magnetic chuck here. It's a precision flat surface. The head can move up and down, rotating these handles here. The table can move back and forth through this handle, and the table can move in and out as well through this handle. So the grinding wheel's put in there. I'm not going to turn it on right now, but you position it. So we'd have the grinder spinning right now. Position it similar to this. To lock the table in place, we need to center the diamond onto the center of this wheel. We can move our table in and out for that. We have to touch off the wheel. We can move the head of the grinder up and down. And I don't have this thing set correctly right now, but if this were moved up our radius, our 5/16 radius, unlock the locks here. Oops. Therefore, you could slowly bring the head down, pivot it like this, and you're going to grind that internal or concave radius on this grinding wheel. Of course, for the magnetic chuck, you'd turn that on and this would clamp down to the table. It's a real powerful magnet. Now, I did not have these arms on the rocker shaft like this. When I ground this, I had these arms off and I individually did them. I had a little repeatable fixture I set them in and clamped them to an angle plate. And then when I got to it, I brought the wheel down, kind of eyeball centered it onto the center of the existing contact area, lowered this down and went back and forth and ground, then reshaped the radius on there. Here we're showing the rounded area of the rocker arm that pushes against the valve stem, and also the grinding wheel that we dressed the radius on. Then it's set up into the surface grinder and run back and forth over the edge of this to put that profile, that radius on there. So here's the rocker shaft and arms reassembled again, and things are back into tolerance. Also showing the radius on the edge of the rocker arms are resurfaced as well. So as far as the tolerance information, I'm picking from two of the Allis Chalmers book. There's one on a 175 and the other is on a WD45. The engines are very similar. They're both 226 cubic inch. The 175s, 170 obviously are newer, and there's been some updates and improvements, but for the most part the head and the valve train, I believe, are all the same or very similar. So the Allis Chalmers book with the WD45 calls out should not have any larger clearance than 9 thousandths between the rocker arms and the shaft, or a combined clearance of 9 thousandths. Anything greater than that should be replaced. And according to the 175 book, the tolerance, I guess new from the factory, are the clearance between the rocker arms and the shaft is 2.5 to 5.5 thousandths. And they say greater than that and you will lose oil pressure. And in the WD45 book, it doesn't say I would lose oil pressure, but it does say the oil flow will not be correct or something along that line. So they're renewed. I don't know how much of a difference it's going to make, but we'll see. The end of the valve is going to make contact with a radius area here, like so. If you can see, the valve is a little narrower than the pad that it's sitting on. And I don't have a picture of this before I resurface this, but they do wear in there. So what we did by regrinding that was just we put a nice true surface back on there, so it will make nice contact with this valve again. Here's our fully assembled rocker arm shaft assembly. Just some notes about this. There's an oil hole going into the center of the shaft, and then of course the shaft is hollow, so oil will distribute all the way to the ends of the shaft, and in the ends of this hollow shaft there's a piece of cork in either end, and then there's a cotter pin that holds them in on either end. So as this thing fills with oil, there are holes through the tube in the locations of the rocker arms, and then there's a hole drilled through the rocker arm and into the bushing. That'll lubricate the rocker arms, and I believe it runs down the rocker arm a little bit too, and into the back into the head area and then back down into the crankcase. Well, I think we'll end the video here, and in the next video we'll be doing some work on the head. Thanks so much for watching, and please subscribe.